So let me ask y'all something. Everybody getting enough fruits and vegetables? No, it's impossible. Actually, the average American right now is getting 1 serving of veggies per day, 0.7 servings of fruit per day. Enough or not? Not even close. So we know that, and the reason why I'm trying to get this out tonight and get this into conversation is because these are principles that I'm going to take and build on for what we're about to talk about this evening. What I'm going to build on is going to be this whole discussion about what's not you, what's critical to your health, but actually is not you. And this is going to be my takeoff point here for this evening's talk, which is healthy gut, healthy body. And really, if you're going to talk about living life to the plus, taking it to the next level, getting up in the morning and saying, yes, man, I'm ready for the day, that's going to be because your digestion is dialed in. And I could call my talk this evening, The Good Gut Critters. Well, somebody in Chicago, I was in Chicago a few weeks ago speaking, and they said, critter? What is a critter, okay? Everybody know in this audience what a critter is? I hope so. Okay, we're talking about bugs, bacteria. So we can call this the good gut bugs. And I want to just, before we get into my talk, just point out a little bit about my own journey. And I kind of started out on this journey toward better health, better nutrition back in 2006, and it was really for one reason, ladies and gentlemen. It was because I was a cycler, been so for about 5 years, was putting in about 10 hours a week on the bike, about 200 miles a week, and I was pretty good. In fact, this particular race I was getting a picture for is called Mountains of Misery. Anybody heard of that race before? Out of Blacksburg, Virginia, it's a 100-mile bike race, and baby, let me tell you something. It is truly Mountains of Misery. Now, I did pretty well in it, finished in about the top 10 in this race, but afterwards, I just didn't feel good. In fact, I had not been feeling good for probably a year, despite the fact that I was taking 20 vitamin pills a day, trying to come up with the right kinds of special drinks and things that I thought would really dial things in. It wasn't working. I just did not feel like I had energy. In fact, it wasn't till this homeschooling mom in my community started to talk to me about this product called Juice Plus that I started thinking, wait a minute, maybe there's something wrong with my understanding about nutrition. And so she introduced this concept to me that I'd never heard of, and it was basically fruits and vegetables in a capsule. And it started to make me think, well, wait a minute, if fruits and vegetables in a capsule are this good, what about whole food nutrition? And this is where I really began to change my whole paradigm about health, about how I would practice medicine. And from that, I have never looked back. And I've been moving forward on my journey toward better and better health through what? Powerful nutrition, through lifestyle change, through the things that we've talked about this evening. All right, well, moving on from that, let me just tell you how my thinking about this whole idea of your good gut bugs, how this has kind of crystallized for me this last April. There was an article in the New York Times, and that New York Times article talked about a study, and just follow with me for a minute, because the researchers, what they did is they took a group of standard American diet eaters, and they fed them a steak. And, guys, we all know that steak may not be the best food for you, and what they were doing is they took this group of people that fed them the steak, and then they measured in the blood a substance called TMAO. And you don't need to know what the name of that is. All you need to know that TMAO is something that if it goes up in your bloodstream, it increases your risk of heart disease by about 2.5 times. You're 2.5 times more likely to have a cardiovascular event when TMAO goes up in your bloodstream if you're at the highest level. Well, then what they did is they took a group of plant eaters, people who eat no meat, and fed them a steak. And what do you think happened? Did TMAO go up in the bloodstream? They ate the steak. It didn't. There was no elevation in that substance. And so then what they did, knowing this was going to happen, they fed the standard diet eaters, and they gave them an antibiotic. Kill off all the bacteria in the intestinal tract, and then feed them a steak again. What happens? No TMAO in the bloodstream. So what does that say? That says that actually it wasn't the steak causing this rise in a toxic substance. It was the bacteria that live inside the intestinal tract of those folks eating a standard American diet. And I would say, you know what? Hey, if every now and then you want to have some high-quality meat, I don't argue with that as long as what you're doing most of the time supports this whole idea of your biome, okay? What is a biome? It is a large, naturally occurring habitat, a community of flora and fauna that occupy a major habitat. So what is an example of a biome? What's a rainforest? It's a coral reef. It's some large area that includes flora and fauna. Have you ever thought of yourself as a biome? I mean, that's kind of a funky concept, isn't it? I mean, you're just one organism, right? No, you're not one organism. Gang, we are more or less a biome. Why? Because we have about 55 trillion cells in our bodies, human cells. But we have 10 times that many bacteria in and on us. Do you know that you're only 10% you? You are 90% bacteria. 99% of the DNA that is supposed to be your human DNA is not. It's bacterial DNA. In fact, 2 to 5 pounds of your weight comes from bacteria, from critters that literally live in and on you. And you know what that makes you? That makes you what I call, and what scientists are now calling, superorganisms. You're literally this conversation between the cells that are inside your intestinal tract, that are not you, that are on your skin, that are all over you, and they are interacting with your human cells in a really amazing and powerful way. And so basically most of that bacterial content lives inside your intestine. And that's what we're going to call what is called the human gut microbiome or intestinal microbiome. So it's a microscopic environment living in your intestinal tract that includes about 10 to 100 trillion bacteria. And you have from this bacteria 100 times as many genes that are bacterial as you do human genes. And that's what makes you a superorganism. Because why? Because if you'll follow back to that experiment that those researchers did, what they showed was that the substance that showed up in those meat-eating peoples that showed up in their bloodstream, it didn't come from their body. Remember, it came from bacteria. So that means that you can actually make give yourself a higher risk of heart disease just because the wrong kinds of bacteria predominated in your intestinal tract at the time you ate that. That means also that if you change your bacteria, that you might have no increase in a toxic or harmful substance. And so we're going to talk about the implications of this. And you know, when I first started reading about this, I was kind of like that scientist. Remember the movie Back to the Future? And this crazy scientist, you know, it must be he was looking for the flux capacitor to go back in time, you know, the DeLorean. You know, I mean, I've been reading this stuff and I've been saying to myself, great Scott, this is crazy. This is wild. How can bacteria literally influence my health and the risk of disease and or the prevention of disease? This is too much to believe, but it's true. You know, here's my wife, Allison, and what I had to say to her is, baby, you're only 10% you. You're 90% bacteria. Can you wrap your minds around this? This is so amazing, and it is very new data. This is now coming out in the last 5 or 10 years. Well, if you want yourself to actually find out what your intestinal microflora mix is, you can actually go online to this group called the American Gut Project, and you can actually get a kit, and you can just send off a swab of your stool. And that may sound gross, but it's pretty cool that they'll analyze it and give you your bacterial breakdown. And then they'll give you your bacterial breakdown compared to other people in your region, other people in the country, other people around the world. And do you know what? They are now developing correlations between your bacterial library and whether you have risk of certain diseases like cancer, heart disease, autoimmune disease, versus health, the likelihood of living longer. That's how important this is. Well, here's my wife's this is her analysis, okay? Let's just pretend that this is my wife's microbiome profile. And what we have to ask ourselves is, what influences at any one given time what bacteria are going to predominate in your intestinal tract? Well, it is your diet. But if your diet includes things like antibiotics, say you're eating a piece of meat that's conventionally produced, it's going to have antibiotics in it. Your dairy products, your eggs may have antibiotics, your cheese, and that's going to kill off those good bacteria, or influence them. If you've had to take an antibiotic, if you've had a procedure, if you've been exposed to pesticides, and then it's your dietary habits. And you know, you have to ask yourself a question, and some of you have probably never asked this before, but a question you might want to start asking yourself is, should I eat that thing right there in the quick stop if a self-respecting bacteria wouldn't eat it? And you know where I start to ask that question is, back in the 60s, there was something that came along that basically could not be broken down by bacteria. A little snack cake, y'all remember that one? Yeah? Everybody hear that? Yeah, I mean, the bottom line is, if they wouldn't be broken down by bacteria, should you be putting them into your body, especially in the context of this discussion? Now you got to think, what I'm feeding my own body is not just for me, because 90% of what I'm putting in my body now is for bacteria. Now that's how this really starts to play out. Well, this is not just true for adults, this is true for kiddos as well. And let me just say that there's a fantastic article that came out in the New York Times by author Michael Pollan, the May 15th edition of the New York Sunday Times Magazine. And that article really does summarize this whole discussion. And it's long, but if you're into this and you're saying, man, I need to know more about this, that's the article to look at. Some of my best friends are germs. So highly recommend that article. Great for the whole idea of getting an idea of the landscape of this, because let me tell you something, y'all are going to hear more and more about this whole concept of the fact that you're not just you, it's bacteria in and on you that are going to influence directly your health. Well, this is my nephew Chace. He's up in Manhattan, you know, and he's 2 years old. Kind of a typical kid because he had a vaginal delivery. And why is that important? Because now we have to think, if you don't deliver a baby vaginally, do you know what? Mama's bacteria are not given to kiddo. And if they're born by C-section, then that's not going to allow that child to have the bacteria that are critical for immunity, for digestion, for all these different things that are important for health. So important, if you can, to have a child delivered normally, naturally. And then breastfeeding. Do you see, breastfeeding is a part of what supports those powerful intestinal microflora. If you're not doing that, then you're not supplying those bacteria everything that they need. So bottom line is, the child's microbacteria and bacterial array in their gut is a little bit different. And one example is, a child's gut has more bacteria that make folate. And in the ages of birth to 3 years old, what is one of the systems, organ systems, that's developing most quickly, most critical to future health? What organ system would that be? Well, immune system is important, but that's going to evolve and develop through the whole life of the person. But in those first 3 years of life, and even in utero, what is that system that is most critical and most dependent actually on folate? The nervous system. So without folate, you do not develop your nervous system normally. And isn't it cool that kids between the ages of birth and 3 years old have bacterial populations that make more folate than after that time frame? So this is just one example of where bacteria literally are responsible for feeding us what we need. Is that not amazing? And let me just talk a minute about mother's milk. You know, we know now that breastfeeding is a good way to start a baby out in the right way, but we have not known why mother's milk contains something called oligosaccharides. These are small little sugars that the human body does not use. And, you know, people have said over the years, well, this is just some sort of evolutionary fluke. Well, no, it's not. It's by design, because those short sugars were never meant for the human body. They were meant to grow Bifidobacterium infantis. And that particular strain of bacteria is critical for immunity, to protect that baby and that growing child from infection. And so these are just some of the examples of where bacteria are critical for health, for our immune function, for things like producing folate. The list goes on and on. And let me just say something about these bacteria that you probably didn't even think of. Why would you? But bacteria talk to each other. We think of these little simple organisms as just kind of sitting there causing problems, but in fact, populations of bacteria within your intestinal tract are talking to each other, kind of like this cartoon. Gosh, I got to figure out who my kinfolk are. You know, hi guys, are you my friends? Literally, these bacteria shed things off their surface that cause other bacteria to either recognize them or say, you're not my friend. And they send off other signals to try to deflect or even suppress those other bacteria. This is a very dynamic relationship that bacteria have with one another. And this whole concept is called quorum sensing. You don't need to necessarily know that. But furthermore, these bacteria like to trade genes with one another. And qualities about one kind of bacteria can be translated into or transferred into another. It's kind of like this cartoon. Hey, big boy, can I have some of your spiny stuff? Sure, sweetheart, just as long as I get some of your arms. I mean, literally, bacteria have a way of giving certain qualities or proteins that they make to other bacteria that don't have that. And I'll give you an example later on. But what is it that bacteria are doing inside us that we've known about for a long time? Well, one example is vitamin K. Does anybody know what vitamin K is critical for? Blood clotting. Who said that? Oh, you're smart. It is. It actually is blood clotting. That's one of the critical things that vitamin K does. But did you know that bacteria are responsible for making vitamin K? That you may or may not have. But that's one of those things that vitamin K, actually that bacteria do, is they make vitamin K. And we've talked about folate already. How about B12? Did you know B12 actually does not come from meat? It actually comes from bacteria that live in the intestinal tract of animals that we then eat. Okay, that's where we're getting our B12 from. It's actually not from meat itself, but from bacteria. There's a little known amino acid byproduct called threonine. Do you know what threonine is good for, anybody? No, this is going to be really good if someone knows this. Anybody? Threonine is an amino acid byproduct that actually has a calming effect on the brain. So there's this connection between the gut and the brain based on bacteria. Isn't that interesting? What about lysine? Anybody know what lysine does? Okay, when you have cold sores, anybody know about taking lysine? Okay, it is one of the remedies for cold sores. And it's interesting that when we get a bad cold and that sore erupts afterwards, do you know that's not the same virus? That's typically a herpes virus. Why do you think that herpes virus causes an outbreak of cold sores after infection or after you have taken an antibiotic? It's probably because you wiped out the bacterial population that's responsible for making lysine that suppresses and fights the virus that causes cold sores. So this is where this gets very interesting, and there's a very practical application. You want to protect those good bacteria, and you want to be aware that, hey, you may end up having cold sores as a result of losing your good bacteria, and that can come through an antibiotic, for example, during the time that you're sick, okay? Phytoestrogens are compounds that are specifically known to act like estrogen, but they're not estrogen. They don't increase your risk of breast cancer, women who are in your menopausal years, but they are certainly helpful in reducing the symptoms of menopause. And so phyto stands for plant, and estrogen is something that acts like an estrogen, and those are in your diet. And what's responsible for activating phytoestrogens include bacteria. Important? Heck yeah, that's important for someone who's waking up in the middle of the night with hot flashes and night sweats. So what about polyphenols? Anybody know what polyphenols are? Anybody heard of resveratrol? Anybody heard of anthocyanidins? These are all things that are found in grapes and berries. They're great antioxidant type compounds, and bacteria are responsible for helping activate them. So these are the things that we know bacteria do that are critical for you to have to get these types of things in your body, in your bloodstream. Well, here's the new story about these bacteria. This is where this gets really interesting. You may not know what bile acids are, but let me just tell you this, that bile acid metabolism is what your liver does, okay? When you talk about detoxifying your body, when you talk about controlling your metabolism, it's through this whole class of compounds called bile acids, okay? So, what is that? Why is that important? Because guess what? If you alter your bile acid metabolism, you change your production of cholesterol. You alter your blood sugar. You change how your body handles fats. You change how your body detoxifies compounds. So this is the implication of having the right kind of bacteria. You're literally going to change your risk of having an elevated cholesterol just because you got the right bacteria. Just because you have the right bacteria, you may end up having a lower risk of diabetes, a lower risk of weight gain, a lower risk of having damage to your liver if it's exposed to certain toxins, because bacteria make something called glutathione. Glutathione is the most powerful detoxing molecule in your liver, okay? For example, if you're taking too much Tylenol, Tylenol lowers and depletes your body of glutathione. What's responsible for helping your body regain that glutathione? It is bacteria. That's where you're dependent, whether you knew it or not, on your bacteria for nutrients, for protecting your liver. This is getting pretty cool, isn't it? I mean, I'm amazed at this. But here's where it really boils down to it, is an animal experience. What they saw, experiments, was they took skinny mice. And they said, what's making that mouse's metabolism so different? Let's take a group of mice that are germ-free, and let's breed them, and let's see what happens. And guess what? Those kinds of mice would gain weight. And then they decided to get rid of all the bacteria in the overweight mouse that was had an insulin resistance or even diabetes. And they said, let's put the bacteria from the skinny mouse into the fat mouse. And let's see if that makes a difference. And what happens is the fat mouse gets skinny. You literally change the metabolic profile of the overweight or obese mouse simply by getting rid of its bacteria and instilling that fat mouse with the skinny mouse's bacteria. And guess what we did? We did this in humans as well. So researchers in Sweden have taken groups of people with metabolic syndrome who are overweight. They've given them an antibiotic. Then they've then taken the lean person's bacteria, put them into the colon of this overweight group, and guess what? They reversed their metabolic syndrome, and they got lean. This is pretty amazing. Do you now begin to see where this discussion is really relevant to every single person in this room? That if you have the wrong kind of bacteria, that you may be battling a problem that's not you. It's your bacterial population. Here's a really cool little experiment. I'm going to call this little mouse Henry. Y'all remember that movie, Little Shop of Horrors? Anybody remember that movie? Okay. You know, and the Four Tops, one of the guys from the Four Tops was the voice behind the cabbage that was trying to eat, eat everything, and it said, "Feed me, Seymour. I want some more food." Well, I'm going to tell you something. This mouse right here cannot get enough food. And what is the single problem with this mouse? This mouse is bred without a receptor that talks to the intestinal microbiome. That is the single genetic defect. And because this mouse has this single genetic defect, it has excess weight, excess appetite, and is becoming diabetic. That's amazing. This doesn't have to do with some strange mechanism in the liver or in the human cells. This is simply because, or in its cells, it's simply because the mouse's body cannot talk to the bacteria inside its intestine. That's pretty amazing. All right, well, let me just throw something out here. Actually, did you know that the bacteria that may predominate in your intestine may or may not protect you from a urinary tract infection? And for years in my practice, what I've told, especially my female patients, is, if you're having trouble with recurrent bladder infections, and you may have heard this too, eat yogurt or take some probiotics. And when I made that recommendation, I kind of figured, well, the probiotics are going to get down there and kind of colonize the area where bacteria might be getting up into the bladder. That's not how this works at all. The bacteria inside the intestinal tract are making a substance that circulates in the bloodstream to the kidneys, signaling the kidney cells to make something else that then goes down the urinary tract and makes those cells slippery. And this is how bacteria get in. If they get into the bladder, if they get into the urinary tract, they don't stick. And that's how bacteria inside your intestinal tract are literally protecting you from a urinary tract infection, a bladder infection. That's pretty crazy, isn't it? That it's this connected. I mean, this is where you begin to see, man, I'm dependent on these things. This is pretty cool. Let me not ask you to get overwhelmed with this diagram, but let me just point some things out here. Right up here, if y'all can see this, are microbes. Microbes are bacteria, okay? Well, these microbes are shedding pieces and parts of their cell surface. We'll call them little bits of protein or what are called signaling molecules. And what these things do, they're in this diagram called immunomodulins, and they go across the intestinal wall, and they're, of course, making nutrients like B12 and folate, vitamin K, and they're also making little energy things that supply literally energy to the intestinal tract. But when they get across here, they begin to attract and talk to your immune cells. And 70%, ladies and gentlemen, of your immune system lives one place, your gut. So most of the bacteria in and on your body live inside the intestinal tract, and then most of your immune system lives around your intestinal tract as well. So what are we saying here? That the bacteria that are here influence the likelihood of you having a normal immune system or an abnormal immune system or even an immune system that develops problems with lupus, rheumatoid arthritis, fibromyalgia, all kinds of autoimmune diseases. Do you know why those are happening in our day and age? I am convinced that these are happening because we are wiping out and influencing our bacterial balance inside our intestinal tract, our gut, and then guess what happens? Our gut immune system is like this defense. You can think of sentries on a wall, and they're looking down on the inside of the intestinal tract, the gut, and they're saying, where are our friends? Are our friends there? And the good bacteria and the good guys come back and say, we're here, just relax, we got you covered. And then suddenly, that person's exposed to a toxin. That person gets on a long-term antibiotic. They have a major surgical procedure. Something happens to them, and guess what? It kills off all the good bacteria. And then the immune system sitting up there in the centers are saying, okay, guys, tell me, are you here? Are you here right now? No response. Wait a minute, are you here? And they're sending out signals to find out whether the bacteria are there, and the signals don't come back. And then guess what happens? The immune system starts to rev itself up, and it starts to see innocent food proteins and things that it would never react to in a way that suddenly is foreign to it, and it looks like an enemy. And guess what you develop? Food allergies. And your body starts to make antibodies to innocent food proteins that then cross-react with your cells, with your tissue. Suddenly, you're inflamed. Suddenly, you've got eczema. Suddenly, you've got strange rashes. Suddenly, you're allergic to half the things you're putting in your body. And you're saying to yourself, what happened to me? Well, do you know what happened to you is you simply have a bacterial imbalance in your intestinal tract, and correcting that could literally remove and reverse your immune problem, your rash. And even this goes as far as autoimmune serious diseases like lupus, rheumatoid arthritis, and chronic inflammatory conditions. This is how critical this is. We're going to see a whole lot more about this, but let me just highlight for you this little simple study they did in Japan, where they saw that Japanese who were eating a certain kind of seaweed couldn't digest it, and simply by continuing to ingest that seaweed, they found that they began to digest it properly. And then they started looking at why that was. And what they found was the enzyme critical to digesting the seaweed was found in the bacteria on the seaweed, but the bacteria inside their intestinal tract initially didn't contain it. And then they began to see that their bacteria adopted that enzyme. Literally, the genes got traded from the bacteria on the seaweed into the host or that person's bacterial population. That's what I'm talking about by trading genes. That's how fluid this is. This is not static. Your genes, the genes of your bacteria can literally start to trade off, both good and bad. And where this is really important also is gum health. See, we have certain bacteria that predominate inside our mouth that are harmful, okay? And here are a couple of them. You don't have to know the names of these, but just know that if your mouth is full of the wrong kind of bacteria, those bacteria literally shut down the normal lining of your mouth. They literally cause the cells that line your mouth to die. But there's another kind of bacteria, this one here called Streptococcus gordonii, and you don't need to know the name. All that to say that this good guy literally sends out signals to shut down the bad guy's behavior. And you know what I take away from this? I say, you know, before you use a mouthwash that is alcohol-based, think that you may be killing off your good bacteria. Yeah, you might be getting rid of a few bad ones that produce cavities and gum disease, but if you're using it long and hard enough, you're going to kill off the good guys too. And that's why I'm telling people, don't use alcohol-based mouthwashes, because then at least you're giving, if you're eating right, you're going to support the growth of the good bacteria that will then naturally shut down those bad bacteria that are producing gum disease and cavities. Well, let's talk about this discussion about energy absorption, because this is really kind of interesting. Did you know, and of course you do, and you probably said to yourself, why can so-and-so eat everything they want and they seem to never gain weight? And here I am, if I just look at food, I gain weight. Anybody had that kind of thought before? I think we all have. Well, what's up with that? Do you know what it may be related to? It may be related to the bacteria that line a certain person's intestinal tract that do not absorb calories. They're not efficient at converting the food into energy that's absorbed and stored by the liver. And so simply by changing your bacterial population, and down the road, I think this is what we're going to do. When someone comes in with diabetes or metabolic syndrome or difficulty with weight gain, guess what you're going to end up doing? Submitting a stool sample. And they're going to be able to say, okay, well, your bacterial predominance tells us that your kind of bacteria absorb and digest way too many calories. Let's change that. Let's give you a specific select antibiotic, knock those out. We're going to give you a different kind of antibiotic, a different kind of bacteria, and we're going to see this reverse. How about that? How about the fact that this frustration of what you thought you were doing was so good all along might have been, but you were hamstrung because you didn't have the right kind of bacteria predominating in your intestinal tract. That's amazing. I mean, I'm blown away by this whole idea that it's not just us, that it's the bacteria in and on us that are partly controlling and maybe mostly responsible for our health. And this goes with vertical transmission. So mom to children, at birth, a mother's bacteria may influence their risk of disease, of weight gain. It's not mom's genes. It's not dad's genes. It's the fact that the wrong kinds of bacteria predominated at birth. And that's where I say, good night. If you're going to take an antibiotic, try not to take one about the time you're delivering your baby, because why? You're killing off a lot of very protective bacteria and altering things that may set your baby up for poor health right at the start of their delivery and their first few months.